Hello, you're welcome to today's lesson. Now we're still treating circle theorems. We have two questions on the board. In number one, we are expected to find ACO. And then we have 116 here at the center, and then 25. So for us to do that, we have to draw a line from A passing through the center to join T. Produce it to T. Okay? So, and we have two isosceles triangles here. Isosceles triangles, that's ABO and ACO. So, from this, we know that solution ABO is equal to BAO, which is 25 degrees, because they are base angles of an isosceles triangle. And then we know that BOC is the same thing as BOT plus COT. So, and for us to get BOT, it means we know that if this is 25, this is 25. That's base angles of isosceles triangle. So, which is equal to BOT should be 25 plus 25, which will give you this. That is 25 degrees, 5 degrees plus COT. And the reason is the sum of two interior angles of a triangle equal to one exterior. And that will give us 50 degrees plus COT. Therefore, 116, which is BOT, is equal to 50 degrees plus COT. So from there we have therefore COT is equal to 116 degrees minus 50 degrees, and that will give us 66 degrees. Then we also know that CAO is equal to ACO, which is equal to 66 degrees over 2. We divide it, and that will give us 33 degrees. Therefore, ACO, which is what we are looking for, ACO is equal to 33 degrees. Now, the reason is that 25 here plus 25 here is 50 degrees. That's the sum of two interior angles of a triangle equal to one exterior. And when we subtracted this 50 from 116, we had 66. Then for us to get either of this, we have to divide that 66 by 2 to give us each of the angles inside. So we say that ACO is equal to 33 degrees. Therefore, Y is equal to 33 degrees. And that's the end of question number 1. So question number 2 now, we'll quickly go over there. In that case, we are trying to find PQR. PQR, that is this angle here. This angle here. And now, by looking at this, we know that PR is equal to Q. PQ is equal to QR. So we need to draw a line from here, from R to P. And before we do that, we know that, that's question number 2 now. You know that QPS plus QRS is equal to 180 degrees, and that is opposite angles of a cyclic quadrilateral. And that means that 62 plus whatever is here will give us 180 degrees. So coming back to this side, that means we are now talking of 62 plus QRS equal to 180 degrees. And that shows that QRS is equal to 180 minus 62 degrees. If you carry out the subtraction, that will give us 8. That is 118. So which means the whole of this is 118. Okay? So that will give us 118 degrees. So if we are to draw a line from here, you know that PRS is equal to 90 degrees, raising angle in a semicircle. That is, since this is the center, angle in a semicircle is always 90 degrees, or use the idea of angle at the center 2 times angle at the circumference. Any of the two, still okay. So in that case, since we know that PRS is equal to 90, and we are looking for PQR, that is this angle. So we have QPR, QPR is the same thing as QRP. That is QPR, the same thing as QRP, and that is the reason is base angles of isosceles triangle. Okay, so I already know that this is 118. So which means to get QPR, therefore QPR should equal to QRP, that is the angle here, should be 118 degrees minus 90 degrees, and that will give us 28 degrees. Now, if we have that as our, that means this angle is 28, this one is also 28. But we know that the 3 will give us 180, that is angle QPR, QRP, and then PQR is 180. So we know that PQR should be equal to 180 degrees minus 2 times 28 degrees. Because this angle here is the same thing as this one. So, and that will give us 180 degrees minus 56 degrees. So coming up again, we now subtract. And in order to do that, we have PQR is equal to 124 degrees. That is, you subtract 180, you are subtracting 56. This is 4, this is 2, this is 1. That is 124 degrees. And that is the answer to question number 2. Please like, share,